Welcome to my tutorial series. This is Shakil Ahmed. In today's tutorial, we will learn how to apply a linear regression using survey weights, basically for survey weighted data. So again, we will be working on National Health and Nutrition and Examination Survey 2005 to 2018. You can apply on any type of survey that is a representative of a population, and when there is a complex survey design, then you need to adjust the survey weight. So we have already cleaned the data, and I have found the survey object as survey design till here. So this is survey design object we have obtained using the primary sampling unit identity and the weight variable. This is weight variable. Every survey has a weight variable and related documentation how the weight was computed. So before applying the survey weight method, you should know about the documentation of weight, how weight was obtained, and how you can adjust for weights, and then stratification variable. So on the basis of this object, we just run the survey design object, and we get survey design object. And today we are going to learn the linear regression model. Basically, linear regression model is used when we have a linear relationship between the covariates or the exposure and the outcome variable. Basically, uh, we are uh, we have different type of studies, including uh, causal inference. That is basically we are checking the impact of risk factors on on the outcome, like different type of exposures in medical studies. And in interventional studies, we see the impact of intervention on the on the response, and we adjust for other variables. Then we need to keep all other variables in the covariate set. So this is simple regression where I am using the physical activity score as dependent variable, and sex and education of the individual are taken as the uh, predictors. So we have survey GLM command. Basically, I am giving no option. It means I am using the linear link function. Linear link function means axes are linearly linked with the outcome variable. And the design object is survey design, and this command is used when any observation is missing in the covariates or in outcome, then that will be removed from your analysis. So we can just run this command, and is giving a warning that is saying that observation with zero weight not used for calculating dispersion. It means while obtaining the dispersion variance, uh, the, the observations with zero weights will be excluded. So this is a survey fit object, and you can see the summary of the survey fit, and this is called fit. I called it fit 1. So you can see the result of the linear regression model. Uh, this is the call package, which is the formula you used, and these are the variables, and these are the coefficients. Basically, this is intercept, and this is the uh, beta coefficient for sex, and this is the beta coefficient for uh, education category 1 and education category 2. We had three categories, so it is giving two categories. Basically, omitted one category that is considered as base baseline uh, category, and the category basically 14.901 is the effect of education on physical activity. It means if the person has higher education than lower education, it means his physical activity uh, reduces by 14.9 score, or you can say this is a decreasing impact on education. Similarly, uh, if one is for male and two is female, then you can say that males are more likely to go for have a higher physical activity score as compared to females. So this is the interpretation of the model, and you can see these two factors are statistically significant. But for don't know category, we don't need any interpretation, but you will need to include this category. Otherwise, your data will be lost if you are excluding this category from the analysis. But if your exposure is education, then you need to exclude this category. This category will affect the interpretation of the higher education uh, as compared to low education level. So these are the significant codes. And if you just want to see the coefficients, you can see the coefficients only. This will give the coefficients only. And if you want to see the residuals, as residuals are important, the pattern of the residuals, and basically we assume that there are term follows a normal distribution that can be checked using the a residual plot or a histogram for residuals. So we can see that it is not normal. So this assumption is not correct, not fulfilling. We can't use a linear regression. You can again confirm using a qqplot, that is quartile and quantile plot. You will see the quantile and quantile plot, and with the fitted line, straight line, that is called QQ line. This line is a straight line. Basically, it's it should be a 45-degree line, but here the data is too skewed uh, toward 4, -4 to 4, but uh, more skewed toward 4. It means it's negatively skewed data residuals. So this we can say that the residual does not follow a normal distribution, so we can't interpret the basically the p-values on the basis of a normal distribution. So we need to apply some other type of regression models, like we can fit a log normal type uh, model for such type of data. So this is just explanation of how you can apply a linear regression, and you can add the interaction as well using the same command. I can show you how you can add the interaction term. You can just multiply these two variables and add as regressor. So you can see Again, we can call it fit2, and you can find summary fit2. I think we need to run fit2 first, and then we can see the summary. Now you will get the interaction of sex for both the categories of the education, for the two dummies corresponding to the education. So that are positive means it means and their joint effect on the physical activity is positive. Although the interpretation of the interaction term is not straightforward, hopefully I will make a video on explaining how we can uh, include the interaction term, and how we can include the higher order terms, and how we can interpret such models. So thank you for watching, and stay tuned for next videos.